something serious not on test.
Just want to do a little bit on character tables to let you digest this a bit. We'll probably have to come back to it again on Monday. The character tables are associated with the point group. So when you get a particular point group, it then has an associated character table. So the properties are established by considering these character tables for the point group. Okay? So the point group essentially gives you a label for the symmetry of the molecule. And then you look at the character table that says how that particular group behaves. So when we do this, the character tables describe how certain functions are mapped in this symmetry group. So if you have a function, it can be anything you want. You can say x squared plus y squared. You can say it's x, y. You can say it's simply x, it's y, it's z. Whatever the function might be, you can take those functions and, using the character table, see how they behave. And so from that, we can then describe the behavior of the molecules. Okay? The behavior of the function in these symmetry operations is labeled by something called the character chi. That thing looks like an X, that's chi. So it's going to have a character. That's why we have a character table. So just want to look at if we have a 2pz orbital. Okay, so here's a 2pz, it's along the z-axis. The wave function, we've got different colors here, indicating that it's different signs. In the upper lobe, it's one sign, the bottom lobe is another sign. Okay, so if we want to just consider some of the symmetry operations performed on a pz orbital. Okay, let's say we want to consider rotation about the z-axis. Okay, we want to do this type of rotation about the z-axis. Well, if we do that type of rotation, nothing changes on that pz orbital. Okay. This end stays up here, this end stays down there. The sign of the wave function doesn't change. Nothing changes. So that is assigning character of 1. 1 is unity. There's no difference, no change. Okay. Let's consider, though, what happens if we do a reflection in the xy plane. Okay, x and y here, so we're defining a horizontal plane. We take that horizontal plane, perform a reflection. This part of the pz orbital comes down here. This part goes up there. Still occupies the same space, but what's happened is the sign of the wave function has changed. Where it was positive, it's now negative. Where it was negative, it's now positive. So the character has changed. That's a sign -1. Okay? So 1, nothing changes. -1, signs are being reversed. That's just to give you some flavor of these characters and where they come from. Just dealing with 1 and -1. We can also get characters of 0, 2, 3, some other unusual numbers. I'm not going to look at that. And what I want to be able to do is give you the basics of these character tables and how to apply them. Okay? So next time we'll look at the character table